Hi everyone, in this video I'm going to show you how to add polynomials. But before that, let us review parts of monomial expression. Let's take these two examples on the right. 2x cubed and xy raised to 4. The parts of monomial expression are numerical coefficients. In this example, the first one, the numerical coefficient, or simply called coefficient, is 2. And on the other example, the numerical coefficient is 1. Literal coefficient. So there are two parts of literal coefficients of a monomial. So on the first example, we have x cubed, and this literal coefficient composed of the variable and the exponent. Variable here is the x and the exponent is 3. On the other example, the literal coefficient is xy raised to 4, in which the variables are xy and the exponents are 1 and 4. Next is the degree. On the first example, cube or 3 is the degree, and on the other example, you add the exponents of the variables, that is 1 plus 4, then the degree is 5. Let us recall how to identify like terms. Terms that contain exactly the same variables raised to the same exponents. Let's have number 1. P, negative P, 6P, 3 halves P. These expressions or terms have the same variables raised to the same exponents, that is P. Therefore, these are like terms. Next example, 2 cube roots of 15 n squared, 2n squared. The common variable raised to the same exponent is n squared. Therefore, these are like terms. Next one, negative 8xy, 3xy, 0.2x. First two terms have the same variables raised to the same exponents, but the third term is different. Therefore, this set of terms are not like terms. Next set, s raised to 6, 25r squared, s raised to 6, rv raised to 6. So obviously, these three terms or expressions don't have the same variables raised to the same exponents. Therefore, they are unlike terms. Next, and the last, negative b cubed d raised to 4 all over 6, b cubed d raised to 4, negative 2b cubed d raised to 4. So these three terms contained exactly the same variables raised to the same exponents, that is b cubed d raised to 4. Therefore, they are like terms. Alright, so let's now start adding monomials. So you can only add monomials if the terms are like or like terms. So the rule for this is to add like monomials, add their numerical coefficients and keep the literal coefficients. Now review your law of exponents. Alright, so 2x plus x equals 3x. So add the numerical coefficients 2 plus 1 and then keep the literal coefficient x. Next example, 5x squared plus 3x squared equals, add the numerical coefficients 5 plus 3 and keep the literal coefficient x squared. So that is 8x squared. Next one, negative 4a cubed b plus a cubed b, add their numerical coefficients. Negative 4 plus 1 is negative 3 and keep the literal coefficient a cubed b. So that is negative 3a cubed b. This time let's add polynomials. So there are two methods that we can use in adding polynomials. So the first one is method 1, using associative property of addition, which states that quantity of a plus b plus c equals a plus the quantity of b plus c. So let's take the first example. Find the sum 3x plus 5 plus 8x minus 3. So let us group the like terms. 3x plus 8x, then plus 5 minus 3. Then simplify. 3x plus 8x, copy the literal coefficient and add their numerical coefficients. So we have 11x plus 5 minus 3 is 2. So the answer is 11x plus 2. Method 2, using vertical addition. Sometimes it is also called the column addition. So with the same example, copy the mean 3x plus 5 and aligned the like terms. So let's just start with 8x, align it with 3x, put it under 3x, and then minus 3, it's under 5. And then simplify. 3x plus 8x is 11x, and then 5 plus negative 3 is positive 2. Next, number 2, 3a squared plus 4a minus 6 plus negative 4a squared plus 7. So we will be using method 1. So we're going to regroup or group the like terms. That is 3a squared minus 4a squared, then plus 4a, then negative 6 plus 7. Then simplify. 3a squared minus 4a squared is negative a squared, or rather negative a squared plus 4a, and then negative 6 plus 7 is plus 1. Therefore, the sum here is negative a squared plus 4a plus 1. Okay, let's apply method 2 for this example. Again, align the minuend and the subtrahend vertically or in column. Make sure that you aligned like terms. So let's start copying the minuend. 3a squared plus 4a minus 6, then plus place negative 2a squared below 3a squared. So there is no second term in the subtrahend, so leave it blank. And then next is the constant term, positive 7 under negative 6, and then simplify. 3a squared plus negative 4a squared is negative a squared. Recall your operation on sign numbers, but particularly addition. Then bring down plus 4a. Then negative 6 plus 7 is positive 1. So the sum is negative a squared plus 4a plus 1. Okay. Third example, method 1. Find the sum of 4y squared plus 9y minus 3 plus 2y squared minus 5y cubed minus 4 minus 8y. This subtrahend is not in descending order, so that's fine. We'll just group the like terms, starting with the degree, or the term with the highest exponent. So there is negative 5y cubed, then followed by 4y squared plus 2y squared, then plus 9y minus 8y, and combine the constants, negative 3 minus 4. Simplify. So copy negative 5y cubed, then 4y squared plus 2y squared is 6y squared. 9y minus 8y is positive y. Then negative 3 minus 4 is negative 7. So the sum is negative 5y cubed plus 6y squared plus y minus 7. Next, method 2, using the vertical addition. Copy the minuend 4y squared plus 9y minus 3. Then align the term or terms of the minuend one after the other. So let's start with positive 2y squared under 4y squared. Next is negative 5y cubed as the leading term. And then negative 4 under negative 3. And then negative 8y under positive 9y. Okay. Plus, minus here serve as the sign of the term after them, or after each of the sign. Alright, so let us simplify. So bring down negative 5y cubed, 4y squared plus positive 2y squared is positive 6y squared, positive 9y plus negative 8y is positive y. Then negative 3 plus negative 4 is negative 7y. So the sum is negative 5y cubed plus 6y squared plus y minus 7. Okay, I hope you've learned something from this. Subtracting polynomials is also available in this channel. Bye!